And here's the actual product, DB30V5A. This comes with small manual which has Chinese text on one side and on the other side there's English, and this is pretty good translation. Most features are explained in this manual, and I'll try to align this paper so you could pause the video and read the text from your display. This manual gives pretty good instructions on how to use the product, so it's time to take a look at the actual module itself. Let's start by checking out what are the main ICs that are used in this module. That's what I'm going to do. I have power supply connected to the input, nothing connected to the output yet, and it's time to switch the power on. And the display doesn't look good on the camera. But luckily I have this semi-transparent plastic which should work. I'll just cut a small piece of it and put it on top of the LED display. And that's much better. This wave you might see going through the display, varying the brightness of the segments, is caused by shutter speed of the camera. This actually looks solid red in the real life. The voltage reading on the display is input voltage. I know that because the LED above the display is lit, and I know the output is switched on because the CV or constant voltage LED is lit. If I turn off the output, that CV LED will be switched off and there's text off on the display. The module will remember all the settings when it's powered off, so if I switch the power off and on again, it does remember that I had switched off the output. It's nice to see the input voltage, but how do I see the output voltage? Well, I press the +/out button and the output voltage will be shown. As the output is switched off, the voltage is 0 volts. Pressing the -/in button will show the input voltage again. But let's leave it to output voltage. When I switch on the output, I can see the 5 volt reading on the display and the CV LED will be lit. I can change the voltage and current limits by pressing the set button, and one digit will blink. Pressing minus and plus buttons will change that digit. Pressing set button will jump to the next digit. Here I'm increasing the voltage a little bit and increasing the current limit as well. Now I'm changing the hundreds in the current and I want to change the tens on the current. I have to press the set button multiple times in order to move from hundreds of milliamps to tens of milliamps because this selector will go only on one direction. Next I'll test the voltage reading on the module against the multimeter that is supposed to have pretty accurate readings according to my previous tests. And at least around 5 volts the reading matches pretty well. Let's see some lower voltages and at the same time let's see how low this can go. Can this go to 0 volts? So far the voltage reading on the module has been the same as on the multimeter, or at least very close to it. And we are very close to the 0 volts. I'll just need to change the last 300 millivolts. And there we go, 0 volts, and it is reading 5 millivolts, so pretty good. Then let's see the accuracy on higher voltages. The reading is still just as good, up to 15 volts, and the difference is next to nothing. Next I'll test the current reading that is on the bottom display. I have changed the multimeter to amps range and I've connected dummy load that is just outside of this frame. Before I turn on the dummy load, I will increase the current limit on this module higher than the current that I'm going to test. And here's another feature that I didn't mention before. When in adjustment mode, waiting for 6 seconds will save the config and go back to the measurement mode. Now I'll switch on the dummy load and let's see the readings. 201, 201, yeah, still the same. I'm increasing the current on the dummy load and it seems that the current reading on the module matches the multimeter just as well as the voltage readings did. I'm seeing errors of maybe 1 count, maybe 2 counts. And the accuracy seems to stay same throughout the range. So I'm pretty happy with the displays or the measurements of this module. The accuracy is great and the precision on both the voltage and current is good enough, at least in my opinion. 10 millivolts and 1 milliamp resolution, that's okay. Next up are some performance tests, and I think I can use these displays to measure the output voltage and current instead of hooking up multimeters. To measure efficiency, I need to measure the input voltage and current, which I will be using these power supplies displays, and for output I will use the modules displays. Both are as accurate as my multimeters are. I've changed the input voltage to 20 volts, so it's easier to calculate the input power. So let's start. 1 watt output and input is 1.7 watts, then 2 watts output and 2.8 on the input, 3 watts output and 3.9 on the input, 4 watts output and 5 watts in. As I increase the current, the efficiency is pretty good throughout the current range that I'm testing. For example, now it's 10 watts output and around 11.7 watts input, which means around 85% efficiency. With such high efficiency, even at higher powers, the power dissipation will be pretty low, and this doesn't need massive cooling systems like linear power supply would need. But this test was just with 20 volt input and 5 volt output. Let's try a little bit smaller voltage difference, 20 volt input and 15 volt output, and again few tests with different currents. And with this smaller voltage difference, I'm seeing even better efficiency levels. For example, here 15 watts output, 16 input, that's 94% efficiency. Next, I'd like to demonstrate the current limiting or constant current feature. I have connected regular red LED on the output, and I will set output voltage to something that is way too high for such LED. But I will change the current limit to 20 milliamps. Then I will turn on the output and let's see what happens. Will the LED survive? And yes, it does. Like you can see, the CC or constant current LED has been lit. The output voltage reading is 2.0 volts and output current is about 20 milliamps. And that is current limiting feature working just like it should work. And I can change the current limit on the fly just like I did with the voltage previously. Now I'll disconnect the LED while the output is turned on, so the output voltage goes to 10 volts, and when I connect the LED, the voltage will go down to match the forward voltage of the LED at the set current limit. One important thing is the output capacitance. There are two 470 microfarad capacitors on the output, and those are charged at 10 volts, and they will slow down the reaction speed of the current limiting feature. I had pretty high expectations of this device and all the expectations were met. This seems to be very good step-down converter module. Definitely good for converting laptop power supply into a adjustable power supply.